In this video, you'll see CART making sense of a repair operation. The repair operation is changing the battery in a cell phone. Sense making involves taking either an image or a sequence of images, like a video, and attaching a narrative to what's taking place in that image or in that sequence of images. It's more than just a collection of objects. They tell a story of something that's going on. In this case, the story is performing a battery replacement operation on a cell phone. To make this work, CART brings together 4 different types of knowledge. First of all, visual representation. What do the objects of interest look like? These are trained up in a CNN so that we can recognize the objects that are of interest to this particular mission. Second is what the mission is itself. That is, what are the steps involved in changing the battery. The third kind of knowledge is understanding of the capabilities of the individual objects. So for example, the phone can hold a battery and a back. The hands can hold objects. What are the properties of the objects? Not just what they look like, but how they can be manipulated. And finally, there's the visual knowledge. Things that are invariant in the visual world. When something is dropped, it falls. When something is picked up, it is sometimes occluded by the hand. This kind of knowledge. So these 4 kinds of knowledge are all brought together to understand what's going on. In this demonstration, you're going to see that CART is following the steps of the mission as the human performs the repair operation, and CART knows where the objects of interest are and it knows where we are in the mission because it understands has made sense of the image sequence up till that point. And we can test that by asking questions of the system at any point to verify that its understanding of the world is actually correct. The visual interpretation is done in 2 steps. The first step involves building a representation based on what the CNN actually sees in a frame, and matching that up with what it saw in the previous frame and tracking the movement of objects using Kalman filters and eliminating noise for things that appear sporadically but which don't form part of the continuing sequence. The second level of interpretation brings in knowledge of the mission and of the parts. This knowledge enables us to assign names of the to the story components of the mission. So there's the original battery and there's the replacement battery. So the second phase builds a representation that is mission-based, and that forms the belief state of CART throughout the execution of the repair mission.
CART is a system that guides a user performing repair tasks using deep learning, active perception, and plan recognition.
This is the diagram of the CART architecture. At the top you see the Pamela mission model. This is a representation of all the potential activities that could be performed either by the robot or the human. In our case, the mission model describes all activities involved in the repair of a phone. This includes the pre- and post conditions of each activity, along with the desired goals of the overall mission. In our case, the successful repair of the phone. Based on the current goals in the mission model, the generative planner is able to define a plan of actions. For human actions, these are the activities that CART expects the observed human to accomplish. For robot actions, these are the activities that the robot will be directed to perform. In this case, those robot actions will be movements and the generation of spoken status or hints that may be useful to the person performing the phone repair. Those robot actions are controlled by the part of the executive called the action dispatcher, In this demonstration, you will see the robot performing primarily two types of actions. One will be providing spoken feedback to the human regarding their process in accomplishing the repair tasks. The other will be the capture of raw video of the scene that includes the person, the object being repaired, along with any spare parts on the table. The primary thing you'll see in this demonstration is the video stream that is continually sent to the machine learning component shown on the bottom. Here, the convolutional neural network, CNN, is used to detect and classify all of the objects and their positions within the scene. Although this is a very rich set of continually updated data, it's unfortunately also very noisy. To provide accurate understanding of the objects within the scene, we apply a knowledge-based filter composed of a set of Kalman filters which remove statistical noise, along with heuristics that ensure consistency with real-world constraints. The result of the machine learning component is a continuous set of filtered observations. Based on those observations, the executive's belief state update module determines the state and relationships of all objects in the plan. In our case, this includes the current state of the phone and the parts, and more significantly, the status of the phone repair plan being accomplished by the person. If the current state of the repair plan indicates the user has gone astray, the generative planner can generate a new recovery plan and share that with the person working on the phone repair. As you will hear, each time the executive determines that a milestone in the repair plan has been accomplished, the robot provides spoken feedback to the user. Here we see a view of the hierarchical task network, the HTN. This is a top-level view of the repair phone activity, which is then decomposed into 4 sub-activities: disassembly, replace parts, reassembly, and then test. You'll see how each of those 4 activities are then decomposed into low-level activities in the TPN. So here we see the temporal plan network representation. The low-level details, these are the tasks that the user actually performs in repairing the phone. You can see that the task consists of removing the back, putting the back on the table, replacing the battery, putting the back on the phone, and then testing at the very end. The system is observing what the user is doing throughout his whole repair process, and then updating the state based on those belief state observations that are made. Here we see the actual video of the repair task being performed by the user, observed by the robot, and then processed by the CART system. On the very far right-hand side, with the DAL logo on the right, you see a tablet which is providing feedback to the user. Below that, you see some voice recognition capabilities in the form of Alexa. And at the top of that, you see a camera which is observing, recording all the imagery of the user, what they're doing on the table. In the very front on the table, you see the phone. It's a cell phone that has a battery that needs to be replaced. Up in the top left, you see the camera's view, the system's view, which will dynamically be classifying and categorizing objects on the table and in the user's hands as to what they are. Here you see both the battery and the cell phone being highlighted. Finally, in the bottom left-hand corner, you'll see the mission plan as shown in its TPN and HTN forms. It will change colors indicating the user's progress in accomplishing the activities of the repair task.
Computer, open CART.
Welcome to CART. What would you like to repair? Please say new repair, followed by the type of object.
New repair, smartphone.
Okay, I found the repair plan for smartphone.
Start repair.
The repair plan for smartphone was successfully started. finished the top-level disassembly task, which is part of the top-level repair phone task.
Computer, open repair status.
You have just completed cart repair place on table. You are just beginning cart repair pickup from table, which is part of the top-level replace parts task, which is part of the top-level repair phone task. You have finished the top-level replace parts task, which is part of the top-level repair phone task.
Computer, open repair status.
You have just completed cart repair install and defunct. You are just beginning cart repair pickup from table, which is part of the top-level reassembly task, which is part of the top-level repair phone task. You have finished the top-level reassembly task, which is part of the top-level repair phone task. The repair task has been completed. Congratulations.
Thank you.